Are you on mute?
Oh, sorry, guys. I was talking. I didn't know I was muted, Yeah.
Yeah.
Cool. Okay. So what we said was, we type alias this type of the lambda. Yeah. So the lambda type alias here type is input as request and returning as response. This is the output. This is the input. Yeah.
Mm.
Yeah. So now we can use that as the type everywhere when we see request coming in, response coming out, going out. No? Yeah.
Yeah.
Okay. So now it's the same copy for the other one, because it's going to be similar way for the authorization as well, isn't it? Authorization is done, authenticate,
Mm.
authenticate. Yeah. How's it going to go? Only the check is going to differ, right? So this bit is going to differ. Otherwise, return the response by executing the input lambda. Yeah. Yeah. Right. So instead of calling this function to do everything in an imperative way, we can do it in a functional way now because we have lambdas, right? So how will we do this? So we'll first create, so we'll have a val as some chain. How are we going to create the chain? We need to first call this guy. No, sorry, yeah, we'll call this guy, but what it needs to take, it doesn't take in anything. Uh, yeah, it doesn't take in anything. The input is nothing, but it will give us a handler, which is a lambda itself. It will take a
Mm-hmm.
response, yeah? So it doesn't need to worry about anything else. But if you want to call this guy, we can we can call it from what this returns. So we can call, we can call authorize with the final response. Can we do this or not? Yeah. And we can now call the authenticate by chaining the other two. You see this? So this is my chain, which is actually going to give me a handler out at the end. This is the handler, you see?
Mm.
I got the handler, so I can also say this is the handler. And now if I know the handler, which is the chain, I can pass in a request. No? Um, so the handler it's taking a request, so I can pass in a request. So what is the request? This. Yeah, we're done. And so here we could say also print this, no?
Mm.
Yeah, print the answer. It dot, no, sorry, what I'm doing. It dot answer. There you go. So if you now run this, we just see the same answer. There you go. Hello, Jason. You see?
Mm.
So we don't need this function anymore. Comment this out. And everything is now created as lambdas, you know?
Right.
See how code is concise now, and also we're using functions and the chaining. This is the chain of,
Mm.
we chain this, whichever that does into this, and whatever that gives out into this. Everything is going to just prepare something that the other one used. So this is returning the response, which is needed here too. But at the same time, it will take the response, will work with the request, and it will check what it has to do, because this has to authorize. So it will check whether the user is authorized or not, like we were
Mm-hmm.
doing by one. Of course, this is easier to read because of it's very imperative, one line at a time. But this is very concise. This is functional. But if you know the functional concepts, lambdas, well, then this will become much easier to read. See, I don't need to care about what these does. All I care about, the main bits, as in, what they do, and then I can just chain up everything in one line. You know,
Okay.
see, so the program will run faster because we're not executing so many lines. We're just executing all of that line we wrote using functional concepts in one line, you know. So
Right.
our program, whoever's program of this will run much, much faster than that version, you know.
Yeah.
Yeah. So that's the highlight here. And also, how to use lambdas so that we can get the design pattern for chain of responsibility. The design pattern is the chain of responsibility, but we're seeing how to use lambda so that we can chain them up, But if you're asking, where to use the chain of responsibility when you see something relies on the other, when you want to chain things up, this
Mm,
output, so this input relies on this output, and this output will be relied on this input,
mm,
So that's how it goes, So then we can immediately think, that's a chain design pattern we should apply. And then if we see that, then probably we can write, lambdas or functions, which would just do those things rather than having a whole big function to do all of that. We can extract them into each unit as functions or lambdas in this case to do
yeah.
them, you know. So it'll be much, much easier to work with as well. So if you want to change anything about the validation, we don't need to come into this function all the time and correct it. Yeah, where's the validation here for me? The validation is, here. The we haven't written the validation yet. Oh, so it could be the same thing, no? So no, actually, no, I copied the wrong one, man. Sorry. This is the authenticate. Yeah, this is the authenticate thing. Yeah, this is the authenticate, but I haven't written the validation for um, validation yet. So it'll be the same thing, right? We have written, but this is the validate, no? See,
Mm,
now I can just quickly copy paste this, because it's going to be the same format everywhere, right? So, but
mhm,
the effect will be just this. Yeah, check will be just that. So this is the validation. Yeah.
mm,
Yeah. Yeah. So that we can validate it too now. Validate the whole thing. Yeah. Yeah. Hello, Jason. But let's see. The failure. Like if you have an empty username, it should fail, no?
yeah.
Yeah, there you go. Illegal argument exception. We can
Oh,
also give in the reasons why this fails, use name or email should not be empty so that we know, right?
okay, yeah.
Yeah, that's the error. So let's print this. Okay. So we'll see the meaningful error message now. There you go. Username or email should not be empty. Yeah. That's it. That's our chain of responsibility. So now I can remove this. I can delete this. I don't need this big function.
Mm,
Everything is now kept in single units as these values, which are the lambdas, You see? Yeah, that's about the chain of responsibility, actually. Yeah. But the takeaway
mm,
for me is, of course, the chain of responsibility design pattern and working with lambdas, and passing them as parameters into another function. That's what we have just done with these when we change these.
mhm,
Yeah. So Charit, so we started off telling what a responsibility of a chain, right? So chain of responsibility. This is a chain of responsibility design pattern, and we said, if Charit, you're there, right?
Yeah.
So if a unit, and say that we have three functions, right? And each of them relies on the other's output. So this takes an input and gives an output, and this relies on that output to be the input and goes on like that. The chain goes on like that, right? So and it gives out the final response for the input came in, right? So then we can immediately think of this as as a chain forming, right? Isn't it? This is what
Yeah.
we say. If these units are relying on the others' input as outputs, then yeah, we can say this is a chain of responsibility. A design pattern of chain of responsibility. And how do we achieve that in Kotlin? that's why we have seen as, we can chain these functions up so that everyone works together, so that the validate, which we call here, will take the previous guy's output as input into it. That's why we are even telling that's the type of the function here. So its input would be another one's output, this handler here, into this, and it gives out a handler, and that's the final chain. So it gives the lambda out, and we execute the lambda here by passing in what is a handler. The handler takes in a request and gives us a response. So it takes the request and it will give us the response out here. So we are chaining things up, Yeah. Yeah. That's about the chain of responsibility though. Any questions? Jason? Sorry. Yeah, you're good with this, right? You understood this, right? The main important bit is, have we understood, at least we've seen it by seeing it. Then, we start writing the same way, using these lambdas and all that, That's how done it, So first, when I first dealt with this, the way of, passing lambdas and using lambdas and, creating them and all that, I was struggling as well. But the moment I start using and writing them again and again, and I'm okay, I can understand it, I can figure it out,
Mm.
Yeah. That's the main important bit here, And then of course, remember, as if you see something relates to each other by chaining things, yeah, then that's the chain of responsibility design.
Yeah.
Yeah, that's it. Cool. That's all I have today too. So the next one is called interpreter. For that, we would need a bit more time, That's like, creating our own language. That's a cool one.
Wow.
Yeah, creating our own language, our domain specific language, DSL. That is nice, man. That's nice. Nice to see them.
So what's the DSL? You just mentioned that.
Yeah, domain specific language. So if you see if you use a language in another language, like you calling SQL statement into your language you're using in Java or Kotlin, that SQL you're using is a domain specific language, right? That is DSL. So we can write our own DSLs to be used in Kotlin because of we can use Kotlin itself, so we can use Kotlin to define another type of language. So we can invent our own language, the programming language actually, which can be used in whoever is using Kotlin. So it's domain specific, domain specific as in this case is specific to Kotlin, but you can use this as a language. So anything as lambdas, we can define our own way of expressing something. That's very cool, man. For that, we'll have to come fresh, otherwise it'll be too much to push this in,
Yeah, I understand.
Yeah. So our README, we can update the README. So, yeah, it's here. We've done this today.
Yeah, can you put a little write up at the top of the
Yes, that's a very good point.
page?
Yes.
Please.
Yeah. So chain of responsibility, how do we see this? So the chain of responsibility is to yeah, when do we see this? So when do we use this? We use this, when we see couple of units working together, but some inputs will become the other's output, right? So someone's output will become the other's input so that we can chain them up. And that's where we will use the chain of responsibility, right? So if some units, I can't type today, I don't know why. Units work, no, if some units need to work, can we say some units or components? If some components will be good, I think components.
Yeah.
Need to work together in a way someone's output will become the other's input. Yeah.
Yeah.
Then we can apply chain of responsibility. Yeah, there you go. Responsibility. scalability. Yeah, happy with this? So if some components need to work together in a way, someone's output will become the other's input, then we can apply chain of responsibility pattern, which is this.
Mm.
Yeah. Others, no, no, yeah. Yeah, that's it. I can comment this. Adding.
Nice.
Cool. Yeah.
And this is the most complex Lambda can get.
Yes. Yeah, I haven't seen more than this, usage of lambdas to get complicated, I mean, I haven't seen more than this. This is the maximum you can go up to. So
Okay.
which is good. I mean, and see, and the thing, and again, I mean, um, if the most important bit, I mean, do we understand how we are defining a lambda with this input and output, and how we're implementing it, and then when this is called, it's going to execute that code. This is deferred execution, because the lambdas will execute when you call it, not the time it's written or anything like that. So this lambda, anything in these brackets, even though we implement it here, will be executed here. When somebody gives in a lambda into it, which is this. So that's how it chains up. But the lambdas work like that, right? So if you need to call a lambda, you need to pass in the input when you call it, right? Isn't it? So this is when we are actually passing in the input it needs, which is a handler, which comes from this. So we are executing everything at the same time so that they're getting chained up. Yeah.
Mm.
Yeah. Yeah. So yeah, things like that. So if you understand those concepts, then it will become easier and easier when we see even, so complex lambdas written. Yeah. So all it matters is, I mean, what's its type? A lambda's type. What its type? This. What is it taking? What is it giving out? It's input and output. That's it. That's all it matters. And then work with it. So you need to satisfy, if it needs to give an output, which is a lambda, we need to output a lambda here. So this thing is a lambda, you see.
Could it take two inputs?
Yeah, why not? You can put two handlers in.
Okay.
Then you need to give in two lambdas in, no?
Could it be a different type, I mean? Like a
Yeah,
handler and
yeah,
something else?
yeah, why not? Int. And then, of course, this is that the handler in int, no? The type
Mm-hmm.
one is handler and int.
But it doesn't necessarily have to return an int, though.
No. But it is failing because, I mean, it doesn't know what it is and that. But
Okay.
you can't take in anything, no?
Yeah, I understand.
Yeah. Can we break this? It's going on now. Yeah. Yeah. So this is the input, but it's a lambda itself, which is taken two inputs, handler and an integer. No?
Yeah.
Yeah. Yeah. Why can't we do this? Because the whole thing is a lambda, no? You could take another one too. I mean, it doesn't matter, doesn't it? Yeah. You could take an
Yeah.
integer and a string and a boolean and all that, I mean, because it's lambda itself. The whole thing is an input. And yeah.
Yeah, because I'm trying to think of it as like a normal function.
Yeah. Yeah. Um, yeah. Because this itself a lambda, and lambda is an anonymous function, right? Everything relies on how many inputs and outputs you give in. So you can probably, this is the best place to have that integer. So if you want to define the input, define it here, because that's what this has defined, right?
Mm-hmm.
So we tell it takes a request and an int and gives a response out. So everywhere you pass an handler, you need to now, I mean, give in two inputs. Yeah. 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 Because of a function base Even if you think of this as a normal function can take any amount of inputs and it can give an output as well, right? It can give any amount of output as well because a function can have inputs as three parameters, integer, string, and it could give any amount of outputs too, you know. So the stuff come out can be integer. Who cares? This is up to you, right? The amount of inputs and outputs you put into this function, and you say, I mean, what's going to come out? This is our output. This is our input. No? The same with the lambdas too. When you define the inputs and output, you are going to tell it. I mean, how many things it's going to take, and what is it going to return as output?
Mm.
Yeah. So that's the concept, you know. But if you stick with that, then everything will just make sense. And I mean, we can deal with this. Yeah. Yeah. That's all today, guys.
Oh, cool.
Cool. Yeah.
That Lambda session there, that was really good, man.
Yeah. I mean, even seeing this is a good thing, because I mean, it'll when you see a simple lambda, which might be so complicated to some others, you see it as, oh, woof, this is easy after you've seen this. This is like I can, if I tell from my track experience, this is like, I mean, running a 400, somebody asked me to run 100 meters,
Mm.
If you practice 400 meters every day, to run 100 meters, and when you go and
Mm.
run 100 meters, it'll be like piece of cake, right? Eating a piece of cake.
Yeah, be enough.
Yeah, it is like that. This is running 400, And then when you
Yeah.
see a simple lambda, we'll be like, oh, come on, this is easy now, you know? Yeah, cool. Cool. Charity, any questions?
Good.
Cool. Did you see the way we are using the lambdas and stuff?
Yeah.
Cool. Yeah, there you go. Right. Shall we end it here and then
Yeah,
yeah.
man. No problem.
Yeah. Yeah. Okay. I'll stop recording.
Okay.